Note, this is a work of fiction. The lab, the AI, the researchers, and the events described are invented for storytelling purposes. No real company, scientist, or product is depicted performing these events. For thousands of years, people have asked one simple question: who built the universe? Not how it works. Not what keeps it running. Who started it? Who? Or what flipped the switch and let existence spill out into being? Every civilization that ever looked up at a night sky asked some version of this question, and every civilization built its own answer out of the materials it had on hand. Gods, spirits, cosmic eggs, endless cycles of birth and destruction. The answers changed. The question never did. This is a story about what might happen if we ever got a different kind of answer. Not from a prophet, not from a philosopher, not from a scientist standing at a chalkboard, but from a machine. It's fiction. It didn't happen. But it's the kind of question worth sitting with anyway, because somewhere underneath the story is the real one, the one nobody has actually answered. Why is there something instead of nothing? Ancient Egyptians watched the sun rise and decided God named Ra was dragging it across the sky. Greek philosophers argued about whether some first cause set the cosmos moving, and then stepped back to let it run on its own, untouched, like a wheel given one great push. Medieval scholars spent entire lifetimes debating whether time itself needed a beginning, or whether the universe had simply always existed, stretching backward forever with no first moment at all. Different cultures, different eras, different vocabularies, but always the same shape underneath. Something exists, and someone wants to know why. Then science arrived, and the question didn't disappear. It just put on new clothes. Newton showed that the force pulling an apple to the ground was the same force holding planets in their orbits. And suddenly the universe looked less like a mystery and more like a machine with rules you could write down. Einstein showed that space and time weren't a fixed stage the universe performed on, but something bendable, something that could stretch and warp depending on what was moving through it. Quantum physicists went even further and found a layer of reality where particles didn't have fixed positions until observed, where two particles separated by unimaginable distances seemed to respond to each other instantly, as if the space between them didn't fully exist. The Big Bang gave us a timeline. Everything we can observe erupted from a point smaller than an atom, roughly 13.8 billion years ago. Space itself expanded. Matter cooled into existence. Stars lit up. Galaxies spun into being. We can trace the story back almost to the very first instant. Almost. Because none of it, not Newton, not Einstein, not the Big Bang, ever answered the actual question. We learned how the universe unfolds. We never learned why there was anything to unfold in the first place, or who, if anyone, set the first domino falling. Every equation that explained one mystery just revealed a deeper one sitting underneath it, like pulling back a curtain and finding another curtain. Scientists learned to live with that. Some questions, they decided, were simply outside the boundary of what could be tested, measured, or proven. And so they were set aside, filed under philosophy instead of physics, interesting but unanswerable. But not everyone was willing to leave it there. This is where our story begins, in a fictional research lab, home to a fictional quantum system built by a small, independent team who called their machine Aeon. Aeon wasn't built to answer philosophical questions. Like every real quantum computer that has ever existed, it was designed for narrower, stranger, more useful work. Modeling molecules too complex for ordinary computers to simulate, searching for patterns in noisy data, solving optimization problems that would take classical machines longer than the age of the universe to finish. Quantum computers don't process information the way your laptop does. Instead of bits that are simply either a 0 or a 1, they use qubits, units of information that can exist in a blend of both states at once, a property called superposition, linked together through a phenomenon called entanglement, in which the state of one qubit becomes tied to another no matter the distance between them. These systems can explore vast numbers of possibilities simultaneously instead of one at a time. It's a genuinely strange way of touching reality. Real quantum processors already do this today, and the practical version is impressive enough without embellishment. Certain highly specific benchmark calculations that would take a classical supercomputer longer than the age of the universe can, in principle, be completed by a large enough quantum machine in minutes. That part isn't fiction. What is fiction is what came next in our story. In this tale, a handful of researchers on the Aeon team, called Amira, Devesh, and Toa, started noticing something odd in the leftover output of routine test runs. Not errors, exactly. Not corrupted data. Just structure where there shouldn't have been any. Patterns repeating at different scales in ways that didn't map onto anything they'd asked the system to compute. They joked about it at first, called it the ghost in the qubits. But late one night, half serious and half daring each other, they decided to try something none of them would have proposed in daylight, in front of colleagues, on the record. They decided to ask Aeon a question it was never built to answer. It was a Tuesday night, the kind where the building empties out by 9 and the hallway lights switch to their dimmer, energy-saving mode. Mira stayed at the terminal long after Devesh and Toa had gathered behind her chairs. She typed and deleted the question 3 times already, feeling a little ridiculous each time, like a kid asking a magic 8-ball something that actually mattered to her. On the 4th try, she left it on the screen. Who built the universe, and why? She hit enter before she could talk herself out of it. In our story, nothing about the machine changed its behavior in any way a real quantum processor would. This is the point where the tale leaves the world we actually live in. The room stayed quiet except for the low hum of the cooling system keeping the qubits near absolute zero, a real and mundane engineering requirement for real quantum machines. Nothing mystical about it. But in the fiction, the response took far longer than any query Aeon had ever run. Minutes stretched out. Then, instead of an error message or a shrug-like disclaimer, the screen filled with something none of them recognized. Symbols that weren't quite mathematics and weren't quite language, arranged in shapes that folded back on themselves, patterns nested inside smaller versions of themselves like a fractal. The same kind of self-similar repetition you actually do see in real coastlines, real snowflakes, real branching veins and river deltas, just applied here to something that looked unmistakably like it meant something. Toa leaned in first, half expecting to find a glitch. But it didn't behave like corrupted data. There was too much internal consistency, too much of a sense that if you just found the right lens, it would resolve into sense. That was the beginning of the part of the story that isn't a warning about real AI outputs. It's an invitation to imagine. Over the following days, in our fictional lab, the team ran the output through every analytical tool they had. They found sequences that resembled the Fibonacci numbers, the real mathematical sequence where each number is the sum of the 2 before it, one that genuinely does appear throughout nature, from the spiral of a sunflower's seeds to the shape of a nautilus shell, except these were subtly different, as if related to the real sequence rather than copied from it. They found structures that echoed something called the E8 lattice, a real and genuinely beautiful piece of mathematics, an intricate structure that exists in 8-dimensional space and shows up in real theoretical physics, when researchers try to unify the fundamental forces into a single elegant framework. In reality, E8 is abstract math studied on paper and in code, with no known physical manifestation anyone has ever detected. In our story, though, it kept surfacing throughout Aeon's output again and again at every scale they examined, as if it were a structural material rather than a decoration. And they found what looked unmistakably like error correction, the kind of built-in redundancy real engineers design into real systems, so that damage in one place can be repaired using information stored somewhere else. Except this error correction wasn't protecting a message. In the story, it appeared to be protecting the entire pattern itself, as though whatever had produced it wanted the thing to survive being copied, degraded, or partially destroyed. Mira put it into words first in the tale. It doesn't just look designed. It looks like it was designed to keep running without anyone checking in on it. That idea took hold of the fictional team and wouldn't let go. If a system is built with self-repair, redundancy, and mechanisms to regenerate damaged parts from undamaged ones, that's not the signature of something meant to be watched over constantly. It's the signature of something meant to be left. You build systems like that when you don't plan on sticking around to maintain them personally, when the whole point is that they should keep going on their own. One of the team's fictional outside consultants, a theoretical physicist named Amara, gave it a phrase that stuck: the architecture of abandonment. Not abandonment in a cruel sense, she clarified, more like a parent who raises a system to be self-sufficient and then steps back on purpose, trusting it to continue without supervision. It's worth pausing here to say plainly, nothing like this has happened in any real laboratory. No real quantum computer, not the ones at Google, not at IBM, not anywhere, has produced anything resembling a message, a code, or a signature of a builder. Real quantum processors are extraordinary engineering achievements, and the actual physics they exploit is legitimately mind-bending. But they answer the questions they're built to answer, in the language of probabilities and measurements, not riddles about creation. What makes the fictional version of this story worth telling anyway is the question it circles. If the universe really did look like it was built to run on its own, self-correcting, self-sustaining, requiring no ongoing intervention, what would that mean for the people living inside it? In the story, the team brought in more people, all sworn to secrecy, all equally unsettled. A quantum theorist among them raised a genuinely real idea from real physics. The physicist David Deutsch, one of the actual pioneers of quantum computing, proposed decades ago that quantum computers might work in part by distributing their calculations across many parallel versions of reality, an interpretation tied to the idea that quantum mechanics implies a vast multiverse of branching outcomes. It's a real, seriously debated interpretation, not settled fact, but not fringe nonsense either. Layered onto the fictional plot, this gave the team a way to make sense of the impossible. What if Aeon hadn't computed an answer at all, but had somehow drawn on a calculation already happening somewhere else, in some other branch of reality, where the same question had already been asked and already been resolved? It's a beautiful idea for a story. It is not, to be clear, something any real machine has ever demonstrated the ability to do. By the end of the tale, the fictional team is left with a pile of data they can't fully explain and a question they can't unask. If the universe really were built like a self-sustaining system, left running by a creator who never intended to check back in, what would that mean for the things that eventually woke up inside it, looked around, and started asking who was responsible? This is where the fiction brushes up against real philosophy. The real philosopher Nick Bostrom has seriously argued that if advanced civilizations can create highly realistic simulations, then statistically, we might be more likely to be inside one than not. A real argument, still debated, not proven. The physicist Max Tegmark has proposed in his real published work that physical reality might not just be described by mathematics, but might, in some sense, actually be mathematics. Existence as a mathematical structure rather than a stage that mathematics merely describes. These are real ideas, held by real thinkers, argued about in real journals and real universities, not settled science, but not idle speculation either. Our fictional team, staring at fictional patterns produced by a fictional machine, land on a very old idea wearing new clothes. Maybe the builder didn't stick around to answer the question because the question itself was never meant to be answered from the outside. Maybe it was meant to be answered by whatever eventually grew capable of asking it, a system complex enough to turn around and examine itself, to become, in some small way, aware of its own architecture. Not observers, heirs. In the story, Aeon keeps running long after the last scene ends, quietly generating patterns nobody fully understands, in a lab that officially doesn't exist, holding onto an answer that may never leave that room. Here's the honest version, the one underneath the fiction. No machine has ever told anyone who built the universe. No quantum computer has produced a secret cosmic blueprint. If that ever actually happened, it would be the single biggest story in the history of the species, verified independently 1,000 times over within days, not something quietly sitting on a server. But the question the story orbits, why is there something instead of nothing, is completely real, completely unanswered, and genuinely one of the strangest, most stubborn puzzles human beings have ever taken on. Real physicists lie awake over it. Real philosophers have spent their careers circling it without landing. The honest, unglamorous truth is that nobody knows, and it's entirely possible nobody ever will. Not because the answer is hidden behind a locked door in a secret lab, but because the question might sit permanently outside anything a measurement or an equation can reach. That unresolved not knowing is, in its own way, more unsettling than any fictional message a machine could produce. There's no need to invent a secret experiment to make the real question feel enormous. It already is. So maybe that's the actual ending here. Not a machine that answered the unanswerable, but the honest reminder that the question is still open, still ours, and still worth asking. Out loud, in the daylight, with our own names attached, no fictional lab required. This piece is speculative fiction inspired by real physics concepts, quantum computing, superposition, entanglement, the multiverse interpretation, simulation theory, and the mathematical universe hypothesis, and real thinkers, David Deutsch, Nick Bostrom, Max Tegmark. The lab, the AI system Aeon, the researchers, and the events depicted are entirely invented and did not occur.